So this week for our project, we will be incorporating math, specifically geometry and art. And to get started, I wanted you guys to have a basic understanding of some geometric concepts. Some of you may know this already, but it's always a good thing to review. So some of the basic vocab is that you need to be able to identify lines, angles, and vertices. So if we're talking about lines, line segments are straight and connect 2 points together. Parallel lines will never meet. Perpendicular lines make a 90-degree angle and form an L. I'm going to be showing you pictures of these in just a second, but I want to go over the slide first. Angles are formed when two lines join. Right angles are shaped like an L. They equal 90 degrees. A circle is 360 degrees, and a semicircle is 180 degrees. Vertices are the corners where line segments meet. So let's take a look at what this would look if I were to draw this out.
These are parallel lines. Think of train tracks. And just like train tracks, parallel lines can go in either direction. They can be as close together or as far apart, but they will never meet. Perpendicular lines form a right angle. So perpendicular lines is a vertical line that can be dropped and joins another line at a 90-degree angle. It does not have to come in this direction only. Even this could be a perpendicular. This is a 90 degree, this is a 90 degree, so on, so forth. When two line segments meet, for example, if this is line segment AB and it meets a line segment BC, it forms what is called an angle. Now your angles could be less than 90 degrees. For example, if the two arms of the line segments are closer together, it'll form an angle less than 90 degrees, or they could be wider, like so, and form an angle that is greater than 90 degrees. So if I was to drop a perpendicular here, it would form a 90-degree angle to the dotted line. If you have an angle like so, this is less than 90, however, this is more than 90, but when I add them together, it'll always be 180 degrees, which is also a semicircle. Or I could make a whole circle for 360 degrees. Finally, where angles are formed, the corners are called vertices. So for example, if this is the angle, this corner is called the vertex, plural would be vertices. So any polygon or a many-sided figure, for example, a triangle, will have a certain number of vertices. In this case, there's going to be 1, 2, and 3 vertices corresponding to the 3 angles and the 3 sides. So other shapes will have other amounts. For example, a square would have 4 vertices, so on, so forth. So vertices essentially are the corners.
So just like we just learned, there are different kinds of lines. Here are a few more examples where you can see, you can use a ruler to check for perpendicular lines, use a colored pencil to trace a pair of perpendicular lines in each figure. So if you look at these, you know that anywhere that it can form a right angle or 90 degrees, like right here, right here, right here, or right here, those would be your perpendicular lines. These guys right here will not be perpendicular lines. Same thing goes over here. You have to really see where are your 90-degree angles forming. Just because this line segment right here is falling vertically does not mean that it's your perpendicular line. Your perpendicular line actually is this one right here with the perpendicular falling right there, so that it makes the 90-degree angles there. Same thing going over here. Just because this is a vertical line dropping, notice this angle right here is not the perpendicular. In fact, the perpendicular line is right here because it forms the 90 degrees square angles right there. Over here, this is your perpendicular. not this one. So you can challenge yourself a little bit, and then maybe you even draw out these letters and figure out which ones are the letters that have perpendicular line segments. If you look on this side, we have different kinds of angles. If you notice figure A, you have the arms of the line segments wide open. They're not forming an L per se, it's going past the L. So angle A is actually larger than 90 degrees. It's larger than my 90 in my right angle. However, if you look at B, it forms an L. It's an upside down L, but it still forms that 90-degree angle. And so that would be exactly 90 degrees or a right angle. Look at figure C. That has the arms really close together. And in that one, it's forming an angle that is less than 90 degrees. Similarly, D also is an angle that is less than 90 degrees. E also is two arms closer together. It's a squished up L, not a completely open L. So this one is also less than 90 degrees. And F is forming a 90-degree angle, even though it is flipped over. Another thing that in geometry we need to be aware of is transformations. Transformations basically means how can you manipulate an object. You are using the same object, but you are changing its orientation. Some of you will be great at visualizing this in your head, but some of us need physical manipulatives to hold in our hand and actually do this in order to understand how it works. So for example, if you look at the first figure, it has exactly the same parts, but it has been flipped over. This trapezoid is now, instead of being on the left side, is now on the right side. So it has been flipped. This one over here has actually been turned. So you are actually turning this figure over towards the right side, clockwise motion. The last one, figure 3, has actually done what is called a slide. So you take the exact orientation and then you pretty much slide it over to the left. Or if you started here, you're sliding it over to the right. But everything about it is exactly the same. So we have a flip, a turn, and a slide. So you understand that there are different polygons. Polygons are essentially multi-sided figures. So you could have squares are polygons, triangles, hexagons, octagons, so on and so forth. The number of sides a shape has defines its name. So you could do some research on some of the higher order polygons, like a dodecahedron, things like that, and try to figure out what is the relationship between the number of sides or the number of angles that it has and the figure it forms. So over here is just a quick to do, and you will do this. You can start this on Tuesday, but it might take you some time. So you can take your time during the week to finish making these trading cards. And what these are basically blank trading cards where you can figure out what the shape is going to be. You'll draw out the shape here, and then you'll write out the information in the bottom of the card. If you want to print it out, you could also just hand do this on pieces of paper. That's completely fine with me too. You do not need to share this. This is more for you to practice. Here is another example of what they would look like. And if you're stuck on any, you could choose some of these to get you started. So for example, you have the incredible polygon here. This is an octagon, and it tells you the number of sides. It's 8. The number of corners or vertices would also be 8. And then a real world example to challenge yourself, for example, it would be a stop sign is an octagon. And then you have 3D fantastic. So if you have this as your category, you could make a 3D solid out of it. This could be a cube, or this is a cube. And so it has faces here now. So it has 6 faces. Faces are the sides that you can touch. Then it has 12 edges. Edges are these line segments all around it that you connect to make faces. And then the number of vertices are the corners. So you can count up the corners. There are 8 in here. And then a real world example could be a dice is a cube. Here is another one. This is tri-power. So this is a triangle, and you can look through these. This is a trapezoid. You have other super quads like a rectangle. So I've included these. If you are stuck on what to write on the cards, you can use this as a guide to write on it. Your projects, you're going to have 2 art projects. Once you have a pretty good understanding of lines and angles and polygon shapes, you can go ahead and try your hand at these 2 art projects. The first one is called Geometry and Art. You will be making an asymmetrical starburst. And what you'll be doing is that you'll basically start off with a bunch of scattered dots. If you look over here where it says 1, they're starting off with a bunch of scattered dots, no per se arrangement. And then you'll start joining the dots. So you'll draw a line segment 3 to 5 inches long in the center of the paper. That's this guy right here. And then you'll make dots around that line segment, no dots on the horizontal line. You can start with 10 dots, 5 above and 5 below to make it an easier starburst. If you want to get more complicated, you can go with 15 to 20 dots. Connect the dots then, but in a pattern. So for example, you'll connect one end of the line segment to a dot, back to the other end of the line segment, repeat, and then make sure that you're using a ruler so you get nice straight edges. And then after you're done, you'll end up with something like this. So you'll have multiple line segments connected with each other, and it should make an asymmetrical starburst pattern. And another project that you can try out is the FracGeoBot. So you are going to design a robot out of various polygons. So once you've done your shape trading cards, you'll have been exposed to different kinds of polygons like octagons or hexagons or triangles. And then you can use different kinds to actually build out a robot. Now you could do this in a Word document using shape art. Like there's a place in there where you can make and insert shapes, or you could just draw these out, which I think would be easier. So make sure you're using a ruler and being very precise. But the way to make it a little bit more challenging is then you're going to tell me the fraction for each shape. So for example, if you use 3 triangles in your robot, but there are 24 shapes in total that you used, that means the fraction of triangles would be 3 out of 24. Or if I simplify that, that would be 1/8. So 1/8 of the whole GeoBot is made out of triangles. So you can feel free to design more complex bots, or like this one has quite a few shapes in it that are interconnected. You can be creative, but remember to list your fraction ratios. So that is our project for this week. And I look forward to seeing some of your wonderful mathematical art creations. If you have any trouble, you can reach out to me and I can re-explain some of these concepts if you're not familiar with them. Enjoy and have fun.